don't let the title of the presentations fool you. Although we are going to be focusing on an automotive use case, which we think is a great use case for IoT, everything that we talk about is going to be applicable to lots of IoT, industrial IoT use cases. So there's definitely something here for everybody. And the three things that I think we hope that people walk away from this session are, number one is, do you really walk away with a sense of what it takes to succeed in IoT from a business perspective, right? Number one. Number two is a real world example with Mitsubishi talking about their Mitsubishi Connect program and the real value that they're creating for themselves as a company and their customers. And then, we're super happy to announce our partnership, Google Cloud's partnership with Eris, where you're going to hear about their full stack IoT platform and how that helps customers navigate a lot of the complexity in IoT, rapidly innovate, and just deliver that value really quickly to customers. So that's basically what we have in store for you over the next 50 minutes. Sound good? All right. Good interactive crowd. We get a little. Okay. So if you're here for IoT, and the good news is IoT is growing. So just a quick stat that I pulled from a company called IoT Analytics that does competitive research for IoT, industrial IoT, and Industry 4.0 is showing that for enterprises that they surveyed, whereas 12% of enterprises back in 2018 had said they had implemented IoT projects, that number is increasing to 50% by 2021. So a couple things I think to take away from this stat is, number one, there's growth, right? And it's still a little bit early in IoT, but there's a lot of growth happening, there's a lot of innovation happening. This is a very good time to be thinking about IoT. And specifically, one of the things that we see really clearly is this transition where a lot of companies are moving from a proof of concept phase and pilot phase to real deployment of IoT solutions in production. And over the next 3 years, you're going to see this clearly increase, and it's just a stat that kind of indicates that. But this growth does beg a question. And the question I think it begs is, so how do you be successful in this growth? How do you take advantage of it? So I put together this framework, having had the benefit of being in IoT for over the past 6 years, developing an IoT platform, and being here with Google and many of our customers, outlining what we call the 7 steps to business success in IoT. And it's basically a framework, a way to think about how to navigate the daunting, sometimes, set of business considerations, technical considerations, and even sometimes cultural change that has to happen within a company or a customer base in order to really be successful in IoT. So I'm going to step through this quickly, and there's a lot more behind it. But let's just kind of start at the first part, the business case. So the first thing about the business case is you have to have one. I think the biggest indicator, one of the biggest indicators of success that we've seen in working with companies who have embarked on this IoT journey is that the companies have answered 3 fundamental questions really, really well. Number one is, who is my customer? Number 2 is, what is the new value that we want to deliver to them with a connected service? And number 3 is, how does that new customer value then fold back into my business and add value to my business? And ideally, some way to really measure that and show clear ROI. Companies that have done that work are just really set very well to make many of the other business decisions and technical decisions a lot more effectively. If not, we jokingly in my team would refer to something called the IoT cul-de-sac, which is not a dead-end road, but it's kind of like you get down the road for a while, and you realize you haven't really thought through your end game, and you kind of have to turn around and go back and start from the beginning. So number 1. Number 2 is the connected product itself. So this is it. For OEMs, who are often the ones implementing IoT solutions, this is the one that can sound easy because that's what you do, you make a physical product. But when a physical product becomes part of a 24/7 connected service, there can be all sorts of new considerations, as you can imagine. The question is, with a connected car, is it a car with a computer in it, or is it a smartphone on wheels, right? What really is it? And this has impact on everything from mechanical design. All the buttons and knobs that you would normally have still needed if you're now going to control those virtually or via an app, right? That affects the electrical design, electronics design, connectivity design, right? Are you going to use wired networking, Bluetooth, Wi-Fi, Zigbee, cellular? Which type of cellular, right? Where and which regions? Low power, wide area networking. All these considerations that come just into the physical product that are different than if it's not a part of a connected solution. The cloud platform, as you're picking a cloud partner, right? Does that partner bring the global scale, security, tools, capabilities that you need to be the platform upon which a lot of this solution is built? And the user application, so it's kind of an interesting one, because if you look at 2 and 4, right, user applications and the connected product, these are two areas where you're building the part that will interact directly with the customer. And one is physical and one is digital. And you have this kind of interplay between the physical and digital world. And in IoT, as you know, a lot of the value starts to shift from the traditional physical product into the digital world. But this brings up some opportunities, of course, but also some challenges and maybe some culture changes. I think, Brian, you'll talk a little bit about this, because you develop software a lot differently than you develop hardware, but they have to be in sync with each other, right? So sometimes there's even a cultural change in a company that has to take place here. Then, the next step, hopefully, when you're embarking on the IoT journey, you're not just building a connected product, but you are really running a connected business for the benefit of your customers. And what this often means is, how do you integrate data from these services into business systems that you use to run your business every day? If that's a CRM system, if it's a marketing automation platform, if it's an ERP system, if it's ticketing system, right, trouble ticketing. But that's something to really think about, the capabilities of those platforms and the limitations also, and how that ties into the equation. Next, who's heard IoT is all about the data, right? Yeah, show of hands. The hands are a little weak. Everyone's heard that. Or data is the new oil. We got to change this to be a little more renewable. I think we should start saying in IoT, data is the new sunshine. It's too soft. Data is the new sunshine. I think we could let's tag it right now. That's the first time it was said, right? But the point is that IoT is more than just connecting devices and connecting people. There is a lot that can be done and needs to be thought of with the data. What types of new insights can you derive that you can never derive before? What understanding of a customer can you have that you were never able to have before? And this blending of IoT with smart analytics, artificial intelligence, and machine learning is absolutely a trend that we're seeing, and we think the industry is evolving towards as well. Finally, this is probably the most overlooked. When a company goes after the opportunity of the IoT, the companies that also do a really good job of thinking about the obligations that they now are taking on by becoming a 24/7 service provider is really important, because in balancing the opportunity and obligation, when you're a 24/7 service provider, you have a different support expectation from your customers. They expect that 24/7, and if you bake that into the business case and the solution, you have the whole thing together. So it starts and ends with the customer. Starts and ends with the customer. So 2 more quick slides, and then I'm going to pass it on. If you spend much time with me or my team, you're going to hear that no company can do IoT alone. And what we kind of jokingly say, but seriously say too, is there's always 3 legs to the stool to implementing an IoT solution. There's a platform, an enterprise class platform, like Google Cloud Platform. There's the foundation upon which a lot is built. Then there's an ecosystem of partners, of best-in-class partners that really provide hardware, software, connectivity, and those pieces that really either fill in gaps or accelerate innovation from customers. Eris is a great example of a partner that provides this full stack IoT solution with Google Cloud. You'll hear a lot more about that. And then you always need pro services, so platform partners and pro services, because no solution is complete. You always need experts, either domain experts or technology experts, to help bring it all together. So we, as Google Cloud, with respect to IoT, we never engage with customers without bringing in partners. We're always bringing in partners, and there's always the 3 legs of the stool are always there to stand up a solution. And lastly, I'll spend the least amount of time on this, but if you look at from the platform perspective, what Google Cloud brings is a set of managed services that allow companies to connect millions of devices, ingest that data, process, clean, store that data, and then develop those insights and business outcomes that you want. And this is a platform that, with the other two legs of the stool, finally brings the whole solution together for customers. So with that, I would love to hand it off to Brian, who's going to tell you a little bit about Mitsubishi.
Great, thank you. Good morning, everyone. My name is Brian Arnett. I am not an IoT guy.
There you go, 5 days ago.
I need this thing, as you can see. I'm a product planner. I've been a product planner for the OEM industry for over 25 years. I've worked currently work with Mitsubishi Motors, and was recently tasked about 2 years ago to investigate as part of the product planning operation at Mitsubishi Motors to get into this telematics game. We saw a lot of, as you guys know, there's the General Motors and a lot of the OEMs out there are all talking about connected cars and what connected cars means to the OEM industry. And we needed to figure this out. We need to get part of this game. So we started to investigate the telematics industry, and we started talking with many different suppliers, including Eris. And what we quickly learned is that the biggest lesson of all is we come from two completely different worlds. In the automotive industry, we have been building cars for 100 years using waterfall approach to engineering. Our engineers are basically ingrained in their methodology and go through a series of waterfall check gates. And so suddenly when we start bringing in IoT into the onboard environment, into the vehicle, we start to realize that we need to blend these two worlds together. We need to have some type of a hybrid approach between waterfall development and agile development. And so what we're finding is that there's two cultures. And we as an automotive manufacturer, we need to learn how to be more agile. And you'll hear that from probably a lot of OEMs out there from the automotive side. You'll read that how automotive manufacturers need to think faster, need to move faster to be competitive. And so by partnering with Aeris and working on the IoT space, we actually learned how to improve our culture from an engineering perspective to implement more an agile approach to our development and start rethinking basically how we develop vehicles from a more agile point of view, not just a waterfall point of view. So like any good connected car program, we need to start with a vision. So what is it that we want? So essentially we encapsulated our vision as the car will be integrated into the IoT network by advanced connected car technology of Mitsubishi Motors. In the future, our connection to each other and the world around us will only grow. We will be part of the Internet of Things, connecting you more directly to your world. Mitsubishi Connect will provide innovative connected services by applying the information network to provide a more personalized and rich driving experience. And what is really important here is the statement where it says we will be part of the Internet of Things, connecting you more directly to your world. So a lot of times manufacturers think of things as a hardware perspective. We connect a cell phone to a car and we do a remote engine start and we're done. What we need to start thinking about is connecting the customer to the car, not just the devices. And so this is also something that automotive OEMs are starting to think about, is how do we connect our customers into our world, not just bring their devices into our car. So that's something that is very important as we also look at what is our strategy going forward. The US traditionally has been the largest market for telematic services in the United States. Almost all OEM major brands now have some sort of aggressive fitment penetration in connected cars. And as you know, traditionally, most of the automotive profitability, about over a majority of it, is traditionally gained by fixed operation expenses, sale of oil, sale of parts, maintenance, services, things like that. With the growth of electric vehicles rapidly being realized in the marketplace, some of these traditional fixed operational services and some of these traditional revenues are going to disappear. So we need to start thinking about new business models and new ways to generate new future service revenues for things in the automotive sector and becoming more connected to our customers and delivering more on-demand related services through IoT. You can see from the chart here, which is provided by SBD Automotive, by 2025, over 90% of all vehicles shipped to the United States will have an embedded connected and also a smartphone tethered device in the vehicle. So within a very short period of time, within the next 5 years or so, virtually every vehicle shipped in the United States will have some sort of connected device. So you're looking at, a SAR of about 17 million new cars sold every year. So by 2025, you're going to see a rapid expansion of IoT and services being offered in the automotive space. So we have only 5 years to really learn how to get this right. So from a Mitsubishi's perspective, we looked at it from kind of a 3-stage approach, and I guess this is kind of like your stool. First, we looked at it from phase 1 perspective. So we introduced something called a smartphone link display audio. Most people know this as like Android Auto. We introduced the Android Auto capability into our vehicles, and we have a tethered smartphone system in our vehicle where we can do custom OEM applications that are approved by Google and can be downloaded from the Google App Store and put on your cell phone and so forth. Then beginning in 2018, just last year, we introduced Mitsubishi Connect, which is basically a TCU or a telematics control unit or an embedded device that is installed into the vehicle. And then next, or our phase 3, we get into more of the analytics. And this is where we are going to start learning more about our customers, how to service our customers, and how to grow our business and the service retention of our customers through the analytics that we're going to gain through both the data that comes from the TCU and the data that comes from the tethered device. So today, Mitsubishi Connect system is in the market. It launched about a year ago. We offer a 2-year, we call safeguard and remote service bundle with the purchase of any Mitsubishi vehicle that is equipped with this. Safeguard services include things like automatic collision notification, SOS emergency assistance, roadside assistance, stolen vehicle tracking. Remote services include things like remote climate control, remote door lock, car finder, parental settings, things like that. All of which offer connectivity through your smartphone. And you can see the application there in the center. We also offer Google Home capability where you can use Google, talk to your car through the Google Home device to remote start. And so now we're starting to establish a relationship between the customer and the car more directly when you're not in the car. And so that's very important. Typically, OEMs only were able to make a relationship or establish some kind of connection with the customer when they were driving and when they were in the car. Now we're able to start establishing some type of a relationship and starting to be able to provide some branding exercise to those customers when they're away from the car. And so when they have their smartphone or they're at home in the morning getting ready to go, just simply ask Google to start their car, precondition the climate control. So some of the key business challenges that we faced that we were looking at, Mitsubishi generally is a much smaller company than the Toyotas or the Volkswagens of the world. So economies of scale were very important and necessary for us to make a valid business case. As I talked about a little bit earlier about having the business case. So of course we had a business case and we knew right away that in order to make this work, we needed to do it on a global scale. We did not necessarily have the volumes only in the United States, or we didn't have the volumes only in the European market. So we needed to look at this from a big global perspective. And so we started looking at what kind of partnerships we could have in that perspective. And quite frankly, there weren't many, with the exception of maybe Eris. We needed somebody to deliver automotive-grade IoT services on a global scale. We needed a vendor to help us to provide technical leadership and manage the complexities that we were quickly realizing as an automotive manufacturer. We weren't experts in IoT. We were car guys. We needed somebody who could help us become experts and guide us in the IoT place. And lastly, we needed somebody that could be flexible and adapt to the automotive processes as a change request that we constantly make. We're a waterfall development company. We're learning as we go. We needed somebody that was flexible and easy to work with and understood that we're learning along with them. So one of the partners here that will speak next is Aeris, and they have delivered on a lot of this for us and have been able to be really instrumental in helping us manage the complexity and helping me and our team at Mitsubishi worldwide learn the IoT space. The next thing we needed was Mitsubishi needed an end-to-end modular solution that could adapt globally and grow at the speed of the feature innovation. So we needed to look at the stack of technology that was available. And here's basically a picture of Aeris' full stack of services. So the edge client, the connectivity manager, the IoT transition services, the core services, all the TSP services, including the call center operations. You can see the complexity gets quite overwhelming from an automotive manufacturer. So we needed somebody to handle all of this, and then we also needed somebody who would be able to be flexible with this stack in case something were to change in the future, or be able to adjust this stack. So this is one of the key requirements we had of a supplier. And then lastly, as I mentioned, we needed the ability to work with our M&O partner. We currently work with AT&T, the mobile network operators, to provide seamless 4G LTE connectivity, SIM provisioning, turning on the SIM chip, turning off the SIM chip, managing the subscriber statuses. All of that needed to be done. The call center authentication tool needed to be developed from a global perspective, not just in the United States, but also in Europe and around the world. And then we also needed a connectivity, a connected vehicle ecosystem that provides a significant threat for hackers. Basically, the industry needs to have a secure vehicle, right? As we start getting into the IoT space and we start bringing the outside world kind of into our vehicle, one of the biggest concerns of an OEM is the security of the vehicle. Obviously, we are a very heavily regulated industry. I think there's a government agency for just about everything related to the connected car, with NHTSA or the Homeland Security or Department of Transportation or whatever. We are constantly having to report to the government authorities. And so here comes IoT, and we're, oh God, I mean, what government authority do we have to report to now when it comes to this? So security is one of the things we definitely wanted to make sure we had a good handle on. So we needed to secure the vehicle while protecting the driver. We needed the ability to update the hardware, our apps, and our services without inconveniencing our customers. And we needed to be able to differentiate services based upon the identity of the primary owner or the secondary owner, or whether it was a fleet customer or was a retail customer. We have many different types of customers when it comes to purchasing vehicles. And so it's very important when connecting a car to not just connect the car, but to connect the customer. And so in order to connect the customer, we have to know who that customer is, and we have to be able to control and manage that. So that's very, very important, and Aeris has delivered on many of those areas. That's it for me. I'd like to turn it over to Drew, and he could talk to you a little bit about the technical side of the IoT integration.
Thank you, Brian. And thank you. We're so proud and grateful, actually, to have Mitsubishi as a customer of ours. It's fantastic. And I'll just say we use the word automotive grade, those words actually as a bit of a proxy for reliability and security and complexity. And we're really happy that, even though this is a very mature market, actually relative to many IoT markets, that our platform, we're winning among quite a few automakers, which is actually very difficult to become a supplier of automakers. So that automotive grade really does mean something. So if we kind of go through several of the key challenges that Brian mentioned, one of them is complexity. And actually, complexity is one of the key challenges overall in the Internet of Things. It's very difficult, especially for OEMs who are, as Brian mentioned, generally their business has been about making hardware, potentially for 100 years, like in the automotive space. And trying to get to services and software can be really challenging. And there's a lot of of complexity in that. This picture over here on the right is actually just one view of some of that complexity. There's other views that, different views of how that complexity takes shape. And one of the things that Mitsubishi did that was pretty smart to help manage that complexity was they created what I kind of think of as this pyramid of responsibility. So they really only had two main suppliers. They had Eris and they had their hardware TCU provider. And then they counted on those two providers to deliver everything else. So if you kind of go back to Mario's picture, pretty much everything else was delivered by those two providers. So Eris, we delivered the platform with all of those remote operations and the analytics that's there, the UIs, the mobile UI and the smart speaker UIs, the call center, the cloud actually, and the connectivity. We managed all the connectivity as Brian mentioned. And then along with the TCU provider, we actually shared responsibility for the firmware, and I'll talk a little bit more about that in a minute. Okay, and then here on the right, this is a picture of our stacks, a very simplified picture of our stack. And if we go to, again, one of the key challenges that Brian mentioned of how do you actually deliver rapidly, both for the initial launch and then even being able to add additional services ongoing. If you think about a car, it's in the market for 10 years. So you really don't want to have those features frozen for 10 years. And you have to have an architecture then that can support that agility, not just in the delivery of the initial vehicle, but actually ongoing over that 10-year life cycle. So this architecture is key. I'll just walk you through really quickly. Each one of these kind of major boxes here has actually something like 10 to 20 microservices in it. So I'm not going to go through all those, but I will walk you through generally how the architecture looks. So starting down here, the edge client, that's actually software running in the vehicle. So that's actually where we collaborated with the TCU maker to allow us to put that edge client in the vehicle. And that is, if you look at kind of previous generations of connected cars, that is relatively unique. A lot of the previous generation connected cars did not have an edge client that was really an extension of the cloud platform. They actually just aligned on APIs or protocols, and that actually is one of the areas that causes problems with being able to develop rapidly and actually extend the services and platform eventually later on. So we have the edge client. We have our connectivity platform. So our connectivity platform, I'll talk about that in the next slide. The device platform is actually, again, really key for being able to abstract the vehicle from the rest of the services. So the edge client includes capabilities like connection management, authentication, authorization, OTA, all of the local interfaces to actually perform remote operations. All of those capabilities are here, but it communicates back and forth to the device platform in an abstraction that allows us to just make changes here without having to make changes in the full device platform or even in the service platform. So very key for this is actually getting that abstraction correct. And we've seen a lot of platforms, again, where there's tight coupling, especially between here and here, or maybe even between here and there, between the service platform and the edge client that actually constrains those eventual developments. Okay, and just a quick note: if you think about the IoT core actually is one of the microservices here in the device platform. That's part of the communications infrastructure. All right, and then from a connectivity perspective, Eris is actually, we provide connectivity for the Internet of Things in many horizontals. So we have customers or many verticals. We have customers probably in every single Internet of Things vertical in the market. And what we've seen with many years of experience is generally, particularly large programs, they fall apart if the customer really does not pay attention to connectivity. If you really go into the market and you think cellular connectivity is more or less similar to Wi-Fi or wired, and you ignore the complexities of cellular connectivity, then you'll run into problems at scale. There'll be problems if you really just think about it. If you have problems maybe with making calls or connections in a particular room of your house, you can always move to another room or reposition yourself. But a car can't do that. A car sitting in your garage can't do that. So you need to have a connectivity management platform that's really optimized for handling the Internet of Things, which is very different than what you need for consumers and consumer handsets. And then there's other aspects of cellular that come into play, like security, and we'll talk a little bit about security in a minute. Being able to optimize the response times across the cellular connectivity. If you think about a remote operation on your vehicle, you need to have it happen quickly rather than, and actually you have to balance the speed and user experience with the power management that's going on in the vehicle as well. And as Mario mentioned, as we move to from 3G to 4G, even on into 5G, and potentially even incorporating Wi-Fi, you need to have a connectivity management system that can actually handle all of those different modes. All right, and then one of the other challenges that Brian mentioned was security. And with regards to security, you need to really take a security domain approach. There are actually at least 8 major security domains in the connected vehicle space, and each one of those security domains needs attention independently. And then you need to make sure that you cover the full supply chain. If you think about from the time the car is created until the time the car is crushed, there's so many different parts of that life cycle that come into play. And each one of those stages in that life cycle needs to be secured. And then relative to connectivity, again, if you ignore connectivity, something that we see again have seen from customers in the past, that connectivity is a really critical part of the security domain. Again, relative to cellular was designed to be a many-to-many type of communication mechanism, if you think about it. So you have to apply the security mechanisms to turn that many-to-many into a secure private network mechanism. And one of the most famous hacks actually in connected vehicle in the last few years was at least exacerbated by the fact that the connectivity security domain was ignored. So there was in that case, there was a hole in the vehicle on the edge, which in itself was bad, but what happened was the hole was exposed via connectivity so that anybody who was on that connectivity provider could actually access that hole. And it's key here actually to assume that you're never done. You have to regularly scan, and that's also why OTA updates are so critical. All right, and then the last thing, I thought I'd spend a few slides just talking about why Eris is moving to GCP, and we're really proud, as Mario mentioned, to become a partner of Google. And last year, like perhaps some of you, I was sitting here at Google Next, and we were contemplating, potentially moving to GCP. And ultimately, I just want to share some of the reasons why we chose to make that move. So number one, we think of Cloud 2.0 as really Kubernetes. If you think about Cloud 1.0 being really about virtual machines primarily, Cloud 2.0 is about Kubernetes. And of course, Google is creator and the biggest contributor to Kubernetes. But in particular, GCP has really a large lead on managed Kubernetes. So if you look really across the cloud providers and you do your own evaluation like we did, you'll find that in managed Kubernetes, Google actually has a very strong lead. And the way we look at it is, and I love our DevOps team, but if I have to make a choice of hiring one more DevOps person or hiring a data scientist, I'd rather hire the data scientist. And getting a good managed Kubernetes infrastructure in place allows us to control really our DevOps workload. The second reason is about really being customer and developer friendly. And I go back to this quote at the bottom. That's my quote actually of Cloud 1.0 ROIs. If you think about those ROIs, those were really about having your own private data center where you had tens of usually operations, kind of usually standard operations folks, and the ROIs were relatively easy for kind of reducing a large number of operations folks and moving those to be DevOps folks in the cloud. But now your CEO, or when I say your CEO, I mean my CEO, is actually saying, hey, we're still spending too much money in the cloud. What can we do that's an improvement? And again, as we kind of look around the industry at different cloud providers, what we see out of GCP is that just from cost transparency and kind of optimization ease, there are really large advantages in GCP. And I think you can get to some of these same capabilities in some of the other cloud providers, but not nearly as easily. And for us, in our kind of old cloud provider, we actually ended up with 15 separate accounts in order to manage all of the access controls and have the cost visibility that we wanted. And what we see in GCP is it's just tremendously easier to more automatically get that visibility, the access control, and the cost optimizations that we're trying to get to. And then the last big reason is we do see this opportunity to actually collaborate with Google and their customers on making the Internet of Things less complex and easier for OEMs. We really see that nearly every single OEM on the planet is on this journey from unconnected product to connected service. And that's really important, that difference between those words product and service. As Brian mentioned, oftentimes in the automotive space, the only interaction that the actual automaker might have is maybe even just at the point of the dealership. and that might be the last interaction that they have with the customer previously. So the fact that they can have a connected vehicle, they can understand how the consumer and the owner is actually using the vehicle, they can have opportunities to interact with the owner on a regular basis, is really it's a game changer in the business and in the business of many OEMs. So for us, we see some of the areas that we're working with: provisioning at IoT scale in a secure way, seamless connectivity and OTA updates of edge devices. I've mentioned a few times about why that's important in this space. The advanced remote operation services. If you think about, especially in the moving things area, the fact that you have MQTT and IoT Core and some of those things, those are great, but it doesn't make sense for every single OEM to reinvent how remote operations are done. A lot of that needs to be more standardized and shareable and leverageable. And then the automotive-grade edge computing, where if you think about a future where, again, if you think about Web 1.0 to Web 2.0, and Web 1.0, you also had more of very rudimentary kind of logic getting pushed to the edge, to your browser, and then kind of interacting over rudimentary APIs back to the platform. That's a similar thing that's going to happen as in the edge computing area, so that we have the edge computing logic is more of a adaptable, updatable set of logic that can get easily pushed to the edge and interact in a really optimized way with the cloud-based platform. So these are some of the areas that we're really excited about working with Google on and being able to provide to some of Google's customers.